Okay, welcome back, and our next video is going to be on sketching curves and particularly sketching cubic graphs. So, let's get underway. Idea of sketching graphs is the same whether it's quadratic or it's cubic. Fundamental is still the same, the process just changes slightly. So, essentially what we need to do is two things. We need to set y equal to 0 and we need to set x equal to 0 because we want to see where it crosses the axis. So first of all we're going to set y equal to 0, y equal to 0, and second point we're going to set x equal to 0. X equal to 0. Put a space in there, make it look nice and neat. Okay, purpose of this then, setting y equal to 0, that would show us where it crosses the x-axis. So that would show us our x-intercept. And setting x equal to 0, that will show us our y-intercept. In fact, it will just be an intercept, because there's only going to be one. Okay, so let's go through this process. If you get a nice easy one, you might be asked to sketch something like, let's go in red for our example question. Nice easy one, y equals and this is going to be in brackets. It's going to be all factorised, this one, which is what makes it nice and easy. X minus 3, x minus 2, and then x plus 1. Okay, so that's the question you've got to sketch this graph. So, first of all we can set y equal to 0. So we want to see what happens when, or what values of x can take in order to make this y 0. Because it's factorised, you've seen this a million times before, all you need to do is make each of these brackets 0. As soon as I make this bracket 0, the whole thing, these other two will be multiplied by 0, making the result 0, so that makes y 0. That's the purpose of doing this. So in order to make these brackets 0, as I said, you've done this 100 times for your quadratics, you'd say then x equals 3, it can equal 2 in order to make that middle bracket 0, and it can be minus 1 in order to make that final bracket 0. Now, we need to just think about what happens when x is going to be 0. If we think about what would happen when we expand these brackets, usually we make our smiley face, but we've then got a third one, we'd have to go through the whole process again. What will happen is you'll get a cubic term at the start, you'll then get a squared term, you'd then get a coefficient of x, and then you get that single number at the end, that plus c on the end, which is always our y-intercept. Now, actually, that number on the end, that y-intercept, is just going to be our numbers inside the brackets multiplied by one another. So minus 3 times minus 2 times 1. So it doesn't really matter what my first few terms are when I expand all these brackets. What I'm interested in is that one at the end is going to be minus 3 times minus 2 times 1. So that's going to be plus 6 on the end. Okay, so my y-intercept is where y equals 6. So I'm going to put that underneath as well. Y equals 6. So, I draw up an axis. Let's go quickly to the right. Draw up a quick axis. And I'm going to mark on the key points that I've just highlighted. So that was at x is 3. Oh, let's make it slightly larger then. That x is 3. That's x is 2. X is minus 1. And y is 6. Now, we need to know about the shape of our cubic. Hopefully we've seen them before. They kind of make this lovely curve where we go up, down, but then because it's a cubic, not just a quadratic, we go up again and off it goes. That's quite neat. Okay, so there we are, there's our graph, and what we really need to do just to finish it off nicely is just label the points that we've said. So we've said this is 6, this is 2, oh, go below the axis, minus 1. Let's just move that below because it should really be below. What was that? Oh, I've done it wrong, haven't I? There we go, let's start again. Okay, so we can have, this is going to be 6, this is -1, my other x-intercepts were 2 and 3, I think that's right, let's just go back and check. Yep, 3, 2, -1 on the x-axis, and then that value of 6 through the y-intercept. And that's a cubic graph now sketched. Right, now we're going to have to think a little bit more when we move on. What might happen is you might get a repeated root in there. So I'm going to go through another example. Let's go down here, and let's make it look the same. So we'll have example 2, and that's going to be y equals and I'm going to have my bracket. Now it's going to be x plus 1 squared. Don't know if I can do a squared on my typing. That's a shame. I'll draw it on in a second, give myself a bit of space. And that's multiplied by x minus 1. Multiplied by x minus 1. Okay. So there we are. Now I can just draw on top of that where I wanted my square. I want a little 2 in front of, not too bad. X plus 1 squared, x minus 1. So what I've got is I've got this repeated root in here. And we didn't know what to do with a quadratic, but now we've got this cubic. We need to think about what's happening. So, same process. What will make x, what values of x will make y 0? Well, that's where the brackets again are going to become 0. So that's to make this first bracket 0, it would be x will have to equal minus 1. And then also for this second bracket here, to make that 0, that will be where x is 1. Okay. Y-intercept, let's have a think about that when I multiply my brackets together. Now, don't forget that there are 3 brackets here. We've not written this bracket out twice, we've just written the squared instead. It would be the same as x plus 1 kind of there, and then x minus 1. So thinking about the 3 numbers multiplied together to get my plus c term, it's going to be plus 1 times plus 1 again times minus 1. 1 times 1 times minus 1, so y is going to have to be minus 1. Oh, not with my pointer, minus 1. Okay, so where's my axis? Let's go and reach for this, and I'm going to draw an axis, nice, neatish. And what points we got? Minus 1, 1, and minus 1. So we've got this point here, minus 1. Let's mark it in blue. This point here, 1, and minus 1 for the axis. Right. Now, we've got a little bit of a problem. I can't visualise this shape, really. I'm thinking, well, what could it be, this shape? It could be coming, if I use my pointer, could be coming from down here and going up and down and up. Could be coming from here up. Oh no, couldn't do that, but it might come down here, up, down. So there's a number of different possibilities it could be, and we need to just think about which of these 2 really it might be. Now, there are a couple of ways of doing this. First thing that I like to notice is that what we've got is we've got this repeated root here, and this, obviously this one that's repeated because that's squared, so we've essentially got 2 solutions at x being minus 1. So this first point where x is minus 1 is kind of a big deal. It's a little bit of a bigger deal than the other one. 2 things are happening there. Now, if you remember on our quadratics, when we had a repeated root, what it would do is it would come down and it would just kiss the graph. And exactly the same thing happens here. Where we've got a repeated root, it will kiss the graph and go on. It won't strike through the graph, it will just kiss it and then carry on its way. So, if we come from down below, it's going to just peak at that point there. It's going to come down and go through my y-intercept, and then it's going to go off and up. And there's my cubic graph for this situation. So, one way of knowing what must happen is to spot where this happens, where we've got this little 2 really, that's what we're spotting for, that's where it kisses the graph. Now, what your textbook will tell you is to consider points where x tends to infinity and x tends to negative infinity, which is something that a lot of students struggle to get their head around. What I'm going to just show you is what they mean by that. So, what we need to think about is, let's just have a look at, can I go back, I wonder. No, okay. Let me just, I'm going to delete this graph quickly. And we're going to start again, and we're just going to think about it the other way, the way that your book tells you. So, what we're thinking about is the point where x values, look at my thing, where x values tend to infinity. Okay, it looks pretty cool. We've got some nice new notation here. What this means really is we're thinking about plugging large numbers into our equation. So what it means is if we went all the way up this x-axis, we're going to be well away from any of the solutions. It's not going to be muddled in between, and we can see whether it's going to give us a large value coming out, or even a positive value coming out up here, or a negative value coming out down here. And that will dictate kind of how the graph ends, whether it comes up here and it comes out with a positive value, or whether it comes around down and comes out with a negative value. Now, what's quite nice is we know the important points. We know this is -1, we know this is 1, and we know this is also -1. Instead of thinking about it in terms of x tending to infinity, all you could do to make your life a little easier is think, well, what value is this here going to give me? Is this going to give me a positive value, and is the graph going to go off this way? Or is this value here for x going to give us a negative value? And you can just plug that into your equation. So as long as you're outside the range of solutions, it can give you an indicator as to the shape of the graph. So I might, I might think about large numbers, and I might think, well, if I put a large number into the equation, then what's going to happen? Well, it's going to be a large number here, squared, so it's just going to become larger, and then it's going to be a large number still here, because a large number, take away 1, is still a large number. So it's going to be positive number times a positive number times a positive number. A lot of people struggle with that concept. So what we're going to do instead is actually we're going to think about, let's go back, we're going to think about, as I said, a value really close to but outside our solutions. So we can think about what happens when x is 2. So let's go back to our original. So for this one, when x is 2, what happens when I plug 2 into this equation? Well, it's 2 plus 1, which I know is 3, so 3 squared, okay, that's 9, so this bit becomes 9, and then this bracket is going to be 2 minus 1, which is 1, so it's going to be 9 times 1, which equals 9. Now that's quite useful, because now I can see that at this value here, this point here, where x is 2, is going to give me a value of 9. So that shows me the shape of the graph. This is going to exit going higher and higher and higher. And that's slightly easier to kind of get your head around than the idea of x tending to the infinite, x tending to the negative infinite. So I know that I'm up here somewhere, it's going to leave, and it's not going to be a point that I'm going to think about naturally. So there's only really one choice of what it could do. It was either coming down here, kissing the graph there and then down, which we can see that's not right, so it's going to have to be that it comes up here, kisses the graph, down and up, and then exits this way. So I've got to the same solution, but there's just kind of two ways of thinking about that. And that's what we're going to use for our limits as x tends towards infinite. We're just going to think about values outside of our range. Okay, so finally then, last one I want to talk about in this video is where you're going to be asked to factorise. Now, this is actually not as bad as it sounds, factorising a cubic, because in C1 all you'll have is the first one is going to have a solution of x is 0, and I'll show you what I mean by that. The hardest you'll get will be, let's go, am I red? I am, wonderful. Okay, let's go EG3, and you're going to have something like y equals let's just think of one. What could we do? Should we do a hard one? Yeah, okay, let's do a hard one. X cubed, which I can't do, I just established this. X cubed, I think I better write. Let's just attach my scribbles on the end of this. X cubed minus 16x. Okay, now it might be when you get these types of questions and you're asked to factorise, you're not going to be asked to put them into 3 brackets. You're not expected to do that till C2, but in this case, which will happen, you'll have an x in every term, so you can just factor out that x straight away, which makes life a little easier, and it's a good starting point. So just be aware that that's what you're really going to look for. Take out the x first. So if I take out an x first, I'll have y equals x, and then I'm going to have x squared minus 16. Okay, wonderful. Hopefully at this point you're spotting what you should be spotting. And we're looking at this bracket and we're thinking something interesting is happening here. Now, your C1 exam will always test you on your ability to spot this. It will come up at some point in your exam, and I don't know where, it could be anywhere, but you need to be okay. Hopefully you're spotting that what you've got here is the difference of 2 squares, and we need to have it kind of at our fingertips ready to go, and we'll factorise this. And so let's just have a think about how we do that. Just a little recap. Y equals x, and then I'm going to put this x minus 16 into 2 brackets. We know that in the front of the bracket we need to put the square root of this thing. Square root of x squared is quite nice and easy, that's just x. And it's going to be plus and minus square root of, obviously not minus 16, plus and minus the square root of 16. So it's going to be 4 and 4. And we fully factorised it. Now we're back at this situation like we were in, I think in the first example actually, because we don't have a repeated root, where we can set y equal to 0, find out what our x-intercepts, set x equal to 0, and find out obviously the y-intercept as well. Okay, so let's just quickly do this. What value is going to make this first one 0? Well, that's going to be when x is 0. Don't forget that one. A lot of people forget that one. So you've got to remember that that one's there. That's where x equals 0. So we're going to say x, the solution for this, where y is 0, is going to be x equals 0. For this second one, that's going to be where x equals minus 4. And finally the last one here, to make that bracket 0, that's going to be 4. Okay, what happens then when we multiply this out? Well, if we think about it, in fact we don't need to multiply it out, it's already been done for us. The original question, was it multiplied out? There's no plus c value on the end. There's not going to be a plus 1 on the end or a minus 1, it's actually 0. So the y-intercept is also 0. So, what have we got? Let's go across here, draw our axis as usual. Your y and your x. Should label my axis, I've got a bit sloppy recently, a bit lazy. Right, so we've got our x solutions at minus 4, at 4, and then here at 0. And in fact that ties in with what we've said because the y-intercept is also 0. Now, here's a scenario where we've got options. We don't know which shape it is. It could come down here, up and down, and be a negative cubic, or it could be positive, come up here, down, and through and go up. Now, what we're going to have to do is we're going to have to consider when x tends to the infinite, or big numbers, if you like. A big number in this situation is going to be one that's outside of minus 4 and 4. So let's take the next easy one, let's take 5. So what happens when I put 5 into my original equation? Let's have a look at my original equation. What's it going to be? It's going to be 5 times 9 times 1. Cool, that's okay. 5 times 9 times 1. I know that the answer to that, 5 times 9, 45, okay, that's a positive number. So, in terms of my 5 on my axis, we're out here somewhere, and it's positive, it's up here, somewhere like that. I'm just going to put a little dot just to remind me. So actually, what it can't be is down, up, down. It's going to have to come from the bottom, go down, and go up to get up to that 545 that I've just said. Thinking about big numbers, large numbers, x tends to the infinite. Okay, so let's draw on our graph. Let's make it black. Interested if I'm getting a nice colourful graph. Oh, I'm nailing these. Oh, I missed one. Okay. And that's our graph done for and sketched for this graph. Y equals x cubed minus 16x. Okay, so a quick recap. Your cubics are always going to be this shape, this smooth shape, and this one's a positive cubic, and that's positive because the x cubed here, that's positive, and so it's always going to have that shape where it comes from the bottom. Let's go back, where it comes from the bottom here and ends up going at the top here. So it always has that shape, so that's another thing that you can help, another clue that you can use. In fact, have I used 3 positive cubics? I have, that's a shame, I haven't shown you a negative one. Oh well, you can have fun doing that yourself. So what are you going to have to do? Same process before. Set y equal to 0 to find your x-intercepts, set x equal to 0 to find your y-intercepts. And then it's a case of really using all the clues you can. It might be that you get all 3 and there's only one way it will fit in. It might be that you've got a couple of options where you need to consider either where it kisses the graph, or you might have to consider where x tends to the infinite. We'll keep using the fancy posh word. Basically we're going to sub in a value outside of our solutions and see whether it lies as a positive answer up here or a negative answer down here, and then we should be able to fit our cubic in. And that is the end of today's video, and there's the bell. Wonderful.